The first and most important thing to remember when doing a chemistry lab assignment is to wear your protective gear. You should have your goggles and gloves on at all times while chemicals are out in the lab, as well as wearing appropriate clothing with little to no exposed skin. In today's lab, we were tasked with using the pH meter to detect the differences between strong and weak acids and bases. In the video, you will see us setting up the pH meter to calibrate it, gathering the buffers, and writing down all the information we need to track our findings in our lab notebook. A buffer works by resisting changes in pH through either a mixture of weak acid and its conjugate base, or a weak base and its conjugate acid. Because of this pairing, buffers resist any sharp change in pH when additional acid or base are added. You'll see us rinsing and drying off the meter in between each measurement to ensure the meter is clean and prepped to accurately measure the pH. We then put the meter into the buffer solution and typed in the pH indicated for the buffer on the tablet once the number settled down. Then again, rinse and repeat with the other buffer solution. After calibrating the meter, we rinsed and dried it again and began taking measurements of the commonly found household items. The items that we used were orange juice, apple juice, and Sprite. We took down all of the pH measurements in our lab notebook and then moved on to the next step. You will then see us preparing the series of solutions ranging from 0.2 molarity to 10 to the negative fifth molarity for both HCl and acetic acid. The way we did it in lab was a little bit untypical because the laboratory was missing materials, but our TAs improvised and had us use graduated cylinders, pipettes, and flasks to prepare these measurements. We used the M1V1 equals M2V2 formula to find out how much we needed of the acid and water to make the dilutions and made them accordingly. After we made all of our dilutions, we prepped the pH meter to take the pH of a series of solutions that we made. For the first run, we were testing HCl. We measured the pH of the stock first to get our baseline pH, and then we measured each dilution that we made. In between each measurement, we cleaned and dried the pH meter again and took down the pH for each one to see how diluting the acid would cause the pH to rise as the hydrogen ions dissociate into the water and form hydronium ions, so there are less free-floating hydrogen in the solution. We repeated the process with the acetic acid, which is a weak acid, and we saw how we started off with a higher pH. For the dilutions again, the pH increased as hydronium ions were formed. The last thing we did for this lab was preparing a buffer solution by mixing 30 milliliters stock solution of sodium hydroxide with 60 milliliters stock solution of acetic acid. We also measured 30 milliliters of tap water in a beaker and measured the original pH. Then we added 10 milliliters of HCl to the tap water and recorded the new pH. We went on to measure the pH of the buffer before and after adding HCl, and we saw how adding HCl to water affected the pH much more than when we added it to the buffer solution. We believe this is because the buffer didn't have anything for the hydrogen ions to bond to and form hydronium from. We then made sure that everything at our table was cleaned, and we put up all of the equipment that we used and disposed of everything properly.